Once again, hearty welcome to the Math Revision Made Meticulous video series. Topic: Continuity and Differentiability, Logarithmic Differentiation. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answers. Let us first recollect the rules of derivatives and formula of differentiation before we proceed. If u and v are two real functions, u plus v dash is u dash plus or minus v dash. Product rule is u into v, the dash is u v dash plus v u dash. Keep the first, differentiate the second, plus keep the second, differentiate the first. U by v whole dash, that is the division rule, is v square in the denominator, v into u dash minus u into v dash. Denominator square, numerator is numerator into denominator into differentiation of the numerator minus numerator into differentiation of the denominator. Let us very quickly recollect the formula of differentiation, which are very useful in doing problem. X power n into x power n minus 1, root x 1 by 2 root x, e power x, a power x log a, log x 1 by x, sin x, cos x minus sin x, tan x secant square x, cosecant x minus cosecant x cot x, secant x tan x, cot x minus cosecant square x, sin inverse 1 upon root 1 minus x square, cos inverse minus 1 upon root 1 minus x square, and tan inverse 1 upon 1 plus x square. Well, let us see where we got to use logarithmic differentiation. Now consider this function u of x whole power v of x, that is function power function. For example, y is x power x, cos x power sin x, x power sin x plus cos x power x. Like this, when you see these types of functions are function power function, they are differentiated by taking logarithm to base e on both sides. Logarithmic differentiation will be applied to problems where we have to differentiation of function power function, cos power sin, sin power tan, x power sin, cos power x, x power log, log x power x, like that. Okay, well, what are the method we have to follow? Logarithmic differentiation is applied for this function y is equal to f of x, where function power function, and we will always have many terms multiplied or divided. Suppose it is having a cluster of so many terms are multiplied and divided, and suppose the function is given inside a very huge square root, cube root, nth root, like that, logarithmic differentiation will help you. How to do it? Take logarithm on both sides, use properties of logarithm and simplify. Differentiate terms in both LHS and RHS, express it as dy by dx. Here in this problem it will be not in most probably implicit, it will be explicit. Therefore dy by dx should be expressed in terms of x only. Well, before we go further, we have to check out the properties of log. Log mn is log m plus log n, log m upon n is log m minus log n, log m power p is p log m. Power will come to the front and log of the base. There is no formula for log of m plus n, be careful. Well, then d by dx of log y is 1 by y into dy by dx, because it will be always coming to you whenever you are doing any problem. Whenever you take log, it will come log y in most of the problem. Therefore, please keep it in mind. What is the differentiation of log y? It is 1 by y into dy by dx. Suppose you have right hand side, you will have so many log of any function. So log of tan inverse x, if you get, you have to use 1 by tan inverse and d by dx of tan inverse. We already discussed it in chain rule, but please recollect it while you are doing problems over here, because you will be using the chain rule to differentiate log of a function. Log of log x is 1 by log x into differentiation of log x. The answer is 1 by x log x. Well, let us now go for 1 or 2 problems before we start our 5 questions. If it is x power tan x, no other way out, we have to take a logarithm on both sides. Take log on both sides. Log y is equal to log of x tan x. Whenever the power will come to the front, therefore tan x into log x. Right hand side, you are having 2 functions. You have to use uv formula. Keep tan x, differentiate log x. Keep log x, differentiate tan x. Left hand side differentiation is 1 by y dy by dx. Therefore you got the answer as dy by dx, like this. But you have to replace y at the end. Right hand side should be fully made up of x. Well, if you have this problem like this, suppose so many terms are got multiplied, this problem can be done by 2 ways. You can expand it, you will get a cubic polynomial and you can solve it. But when you use logarithm, it will be very, very easy. Log of 3 terms, therefore log of the first plus log of the second plus log of the third. when you use the differentiation, 1 by that plus 1 by plus 1 by, very simple, multiply with y and problem is over. Okay, well, let us move on to questions now. Question number 1. By seeing this question itself, we are having a very big square root and there are 5 terms, 2 terms in the numerator, 2 terms in the denominator. No other way out, we have to take logarithm on both sides. First of all, we will check out what is the square root. It is whole power 1 by 2. When I take log on both sides, log y is equal to half will come to the front, log of the whole expression. This expression is containing some terms in the numerator, some terms in the denominator. For log of the numerator minus log of the denominator. Once again, the numerator is log of product of 2 terms, therefore log of x minus 1 plus log of x minus 2. Denominator log of product of 3 terms, for log of x minus 3, log of x minus 4 and log of x minus 5. Minus minus everywhere, minus for you are having plus plus but minus is multiply. Now very easy to differentiate. Log of something is 1 upon x minus y, differentiation of x minus y is 1, for no need to write it. Similarly, log of x minus 2 is 1 upon x minus 2. Similarly, 1 upon x minus 3, 1 upon x minus 4, 1 upon x minus 5. And we have to multiply that y. I am just multiplying. There is no need to take LCM and all. You can give the answer just like that. Half into whatever given there, square, that is y given, into 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5. You are seeing over here how the problem is very simple when you use logarithms. Well, let us go to the next question. This is a product of trigonometric function. This problem can be done by making use of that, writing the product in terms of sum like that. But if you use logarithm, this problem will be very, very simple. I will take y as product of the 3 trigonometric functions. I will take logarithm on both sides. Log of cos x, cos 2x and cos 3x. Therefore, it will be log of cos x plus log of cos 2x and log of cos 3x. What is the differentiation of left hand side? 1 by y dy by dx. Right hand side, log of cos x is 1 by cos x and differentiation of cos x is in chain rule. Log of cos 2x, 1 by cos 2x into differentiation of cos 2x. Log of cos 3x is 1 by cos 3x into differentiation of cos 3x. Once again, use the chain rule. What is the differentiation of cos x? Minus sign. Differentiation of cos 2, minus sin 2x into differentiation of 2x. Differentiation of cos 3x, 1 minus sin 3x into differentiation of sin 3x. Well, now we got the numbers now, and sin by cos is tan, all of you know. Therefore, I am writing the final answer by multiplying by y. For y dy by dx is minus cos 2x cos 3x into tan x plus 2 tan 2x plus 3 tan 3x. Well, let us move on to the next question, where it is cos x power y is equal to sin y power x. Trigonometric function power y and trigonometric function power x. As usual, take log on both sides. Power will come to the front. Y log cos x, x log sin y, and differentiate both sides with respect to x. Use UV form in the left hand side. Keep y, differentiate log cos x. Keep log x as differentiate y. Right hand side, keep x, differentiate log sin y. Log sin y keep and differentiate x. Now use the chain rule. What is the differentiation of log cos x? It is 1 by cos into d by dx of cos. On the right hand side, what is the differentiation of log sin y? 1 by sin y into differentiation of sin y. Well, then I am using once again, what is that differentiation of y? That is dy by dx. Well, now we are continuing, and here it is sin by cos is tan, therefore I am using it. Cos by sin is cot, I am using it. I am collecting all dy by dx to one side and pushing it to the right hand side. Therefore, dy by dx is log sin y plus y tan x by log of cos x by minus x. Okay, well, now this y we have just multiplied. There won't be any problem in that. Therefore, all of you know how to do it. Well, okay, now differentiate functions with respect to x once again. It is x power x cos x plus x square plus 1 by x square minus 1. Here be careful, we cannot take logarithm on both sides because log m plus n formula is not there. How to tackle it? You keep the first function as u, take the second function as v. Write it as u plus v. When you differentiate it, you will get du by dx plus dv by dx. The meaning is differentiate the first one separately, differentiate the second one separately and add them. Well, let me take the first one. U is equal to x power x cos x. Take log. power will come to the front into log x. Here, highly interesting, we are getting three functions, x, cos x, log x. You have to use UVW formula. Therefore, keep x cos x, differentiate log x. Keep x log x, differentiate cos x. Keep cos x log x and differentiate x. All of you know how to use this formula. UVW, UV into differentiation of W plus UW into differentiation of V plus VW into differentiation of U. Well, now we are just applying the formula directly. There is no chain rule to be applied over here. Therefore, I am multiplying 1 by U, x cos x by x minus x log x into sin x minus plus cos x into log x. Well, therefore, I am getting that what is the du by dx now by doing some simplifications. Now, I am pushing the u to the right hand side. U is nothing but x power x cos x into 1 plus log x minus x sin x into log x. Normal simplification I have done. I will call it as equation number 2 and keep it ready. Let us go to the next one. V is equal to x square plus 1 by x square minus 1. This can be done by direct differentiation also, making use of that division rule. But when you take log, it is very easy. Log V is equal to log of x square plus 1 by x square minus 1. Log of the numerator minus log of the denominator. Differentiate both sides now. Log V differentiation is 1 by V dV by dx. Differentiation of log of x square plus 1. Use chain rule. 1 upon x square plus 1. Differentiation of x square plus 1. Minus 1 upon x square minus 1. Differentiation of x square minus 1. Both are 2x. Therefore, you got 2x upon x square plus 1 minus 2x upon x square minus 1. Therefore, I can push that v to the right hand side. Therefore, it is x square plus 1 upon x square minus 1 into 2x upon that. Okay. Now, you can take LCM. This x square plus 1, x square minus 1 can be taken LCM. And I have done it so that if there is any possibility of simplification, it will get simplified. And it is getting simplified now. The numerator is coming as minus 4x by x square minus 1 the whole square, because x square plus 1 getting cancelled. Well, I am calling this as equation number 3. Now I started with dy by dx is equal to du by dx plus dv by dx. I have differentiated du by dx separately. I have using log. And I have differentiated dv by dx separately using logarithmic differentiation. Add them and give the answer. Finish. Very simple. Okay. If there is any possibility, you can simplify. Well, let us go to question number 5. Once again, this is also a question where two functions are added up. Don't take logarithm directly. Take the first function as u, second function as v, and do the differentiation. Well, let me call u plus v, where I am taking u as the sin x power x and v as sin inverse root x. Okay, fine. Therefore, dy by dx is du by dx plus dv by dx. I am calling it as equation number 1. Well, let me take u is equal to sin x power x. Take log on both sides. Power will come to the front. Therefore, log u is equal to x log sin x. UV formula to be applied on the right hand side. 1 by u du by dx left hand side differentiation. Right hand side keep x differentiate log sin x plus keep log sin x differentiate x. How to differentiate log sin x? It is a chain rule. 1 by sin x into differentiation of sin x. Differentiation of x is 1. Therefore, x into 1 by sin x cos x plus log sin x, which is nothing but x into cot x plus log sin x. I am pushing that u to the right hand side. Therefore, it will be sin x power x into x cot x plus log sin x. I call it as equation number 1. Sorry, equation number 2. Now, let me go to the v now. V is sin inverse root x. Now, there is no need to take log on this. This is a direct function which can be done by chain rule. Therefore, differentiate directly 1 by square root of 1 minus root x the whole square, because sin inverse x is 1 upon root 1 minus x square. What is the differentiation of root x? It is 1 by 2 root x. Therefore, you got the answer now. I am calling it as equation number 3. Now, I started with dy by dx as du by dx plus dv by dx. I got du by dx now, and I got dv by dx. I got du by dx using logarithmic differentiation. I got dv by dx by direct differentiation. Add them and you will get the final answer. Well, success is dependent on efforts. All the best.